All right. Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? Now that we can write inequalities based on situations, today we're going to look at solving inequalities. We're going to look at figuring out what solutions might be part of an inequality. And so the key concept here again is that an inequality uses the less than, greater than, less than or equal to, or greater than or equal to signs to compare two expressions. And so here in this left situation, you'll see that x is less than 3. And so this graph represents that, right? Maybe it's how much money do you have? Okay, well, I might have $2, I might have $1, I might not have any dollars, right? But this graph shows me solutions that are lower than 3. Okay. Over here, I see solutions of values greater than or equal to 5, right? How old are you? Well, I'm at least 5 years old. So I might be 6, I might be 8, I might be 10. This arrow suggests that this is going to continue, right? I might be 50, way out here somewhere off the screen. So our first example here is we're going to graph the solution for x is greater than 5. And this really, there's only one small piece to graphing inequalities that I think is confusing, and that's whether the circle is closed or open. And so if we're going to be graphing less than or greater than, so either of these symbols, we are going to draw an open circle on the number. Right? The open circle here shows us that 5 is not a solution. So let's say x represents the number of xylophones. Right? How many xylophones do you have? That's a stupid example. Let's say x represents how old you are. Okay? So if my age is greater than 5, that means I am not 5 years old. Okay? So we could find some solutions, and by find some solutions, what I mean here is I want you to substitute in numbers and see if they are correct. So here we say that 7 and 9 are greater than 5. And you can see that we've substituted in those values for our variable, and that holds true. 7 is greater than 5. 9 is greater than 5. And so step 3, starting at our open circle, right, we want to kind of shade in our line representing the solutions, right? And again, the arrow shows that our solutions go on forever. So if it's less than or greater than, you draw an open circle and you shade the correct direction. All right? So here's an example for you to try. All right? So we're going to graph all the solutions of x is less than 8. So remember, if it is less than or greater than, we draw an open circle at 8. All right, let's check that 7 and 4 are solutions. So is 7 less than 8? Yes, it is. Is 4 less than 8? Yes, it is. Okay, so we're going to shade to the left of our open circle to represent x is less than 8. All right. At the bottom here, something I want you to think about, how does this inequality change if our less than symbol is changed to a greater than symbol? Would this always be the case? And explain. So I want you to think about that and jot your answer down. I would invite you to pause the screen while you're thinking. The second example involves less than or equal to, greater than or equal to. And if it's either of those symbols, right, in this example we have m, the number of miles that I'm willing to walk, is less than 12 1/4, right? Less than or equal to 12 1/4. I draw a filled-in circle. So down here at 12, let's see, that's 12 1/2. Down here at 12 1/4, I draw a filled-in circle. So what I'm looking for right now, right, again, here's my filled-in circle. I'm looking for some values that are less than or equal to 12 1/4, 12 25/100. So I might walk, could be 5. I might walk 3, right? So would you say that 5 is less than or equal to 12 1/4? Yes, yes, I would. Would you say that 3 is less than or equal to 12 25/100? Why, yes, I would. Okay. So what I'm going to do here is I'm going to start at my filled-in solution, my filled-in circle, and I'm going to shade to the left. I'm going to make my circle bigger here, I guess. I'm going to shade to the left, representing those solutions. Again, the only difference here is a filled-in circle versus the open circle. All right, you try this. There are no items on the children's menu that cost more than $8.50. I want you to write an inequality to represent this situation. What are some possible items, costs of items on the children's menu, and I want you to graph your solution. So you're going to do everything here. Pause the screen and try it out. All right. My inequality here is C, the cost is less than or equal to $8.50, right? There are no items that cost more than $8.50. So that means that's the most expensive item. So I drew a filled-in circle here. It's my red circle. I drew it filled in at $8.50. Some possible costs. $5 is less than $8.50. So is $2.50. And so when I graph this, I draw from my closed-in circle, and I drew to the left with an arrow indicating that it would go on technically forever. If you have any questions, please come and see me. Otherwise, you are logging on and completing 4-7. Have a great day.